Okay, minasan, konnichiwa, Zamurai Engineer desu. So today we'll have to continue our live practice problem solving as our laboratory part. And also our lecture part this week, we will convert to problem solving. So definitely we will have to continue. Last meeting, we stopped at timestamp 28 minutes. No? So we are now on this problem and we are going to say that our Excel application is actually using a numerical estimation method. And also, not only our Excel, but also our calculator. Your electronic calculator uses numerical estimates. However, even though they are using numerical estimates, if you can search it, you can actually Google it. What is the specification of Excel data? And you will find out that it is as accurate as possible. Okay, corresponding to the level of current technology. So that is why it is acceptable to us, the result of Excel. And at the same time, we are also using calculator and scientific calculator like this one. Okay, and calculator is also another example of numerical solution, numerical estimate. Okay, so we have actually the formula in finding out the value of thermal expansion using the quadratic model. And as you can see, we entered the scientific notation into this function. No? So we use what? Mode 7 in order to have fx is equal to something. So there are three terms that we already inputted in this calculator. So what we are going to do is to tabulate some values for this data. So let us now, why we have to do gx? What is gx? Start. What is the starting point? Start. So let us start in about what? This is about 350. What is this in the table? 350 or 380? In the table.
Negative 340.
340. So let us start with that amount using our calculator. So start with negative 340. And let us what? 340, then 300, that is 40, 40, 220. Let us do it by what? 40. And let us end in 80. Okay, 80. Step. Let us use 40 as our step. So this is our table. Okay, this is our table. So as you can see in the table, compare it to the table given in the, okay, please screenshot this one. Okay, so please screenshot this one, this table. Okay, what are the numbers in the table? Negative 340, 2.45. Predicted, no? 2.45 is the given in the table, and the red column are values under prediction, and the blue column is also another type of prediction. So there are two types of formula. No? So we are using the upper formula here, the upper part, which is the red part, and the blue part is the lower formula. So we are using the upper part. Okay. Okay. So let us compare with our result. We already able to calculate just like that. Just like that. We are able to calculate. Take note. 340, what is the value? 2.4623. Okay? 340, the value of alpha is 2.4623. Okay? Which is equivalent to the prediction on the table. Okay? The prediction on the table is 2.46 and our prediction is 2.4623. That is equal. Okay? Because we are using 5 significant digits. Okay? So next is 300. So our prediction here is 3.0295, which is equal to the prediction on the textbook. Okay? The textbook says the answer is 3.03, which is also equal to our answer. This is how you can do it using calculator. You can do it at one click of equal sign. Okay? Tabulated automatically. Okay? So let us look for 220. 220 here, meaning the temperature is negative 220. Our prediction is what? 4.045468. If you round this up to 3 significant figures, the answer is the same from the book, which is 4.05. Okay? Let's go to the next one. What is that? Negative 160. So let's go down to negative 160. There is no negative 160 because our period is 40. Okay, 180 then 140. Okay, but we can what? We can use our what's that? The we can use the what is that method? Ratio in proportion. Okay, so we can use that in order to find out the value for negative 160 and negative 180. Okay. So 80, there is no value for 80. Okay. Maybe, okay, I will do the same thing using a step of 40. And then we can get all the actual predicted values of the calculator. Okay. So let us do it again. Let's do it again. Let us move it back. We cannot move back. Why? Why we cannot move back? Okay, let's move back to our equation. So let us press equal sign. Okay, and then just press because we do not have the next function. This calculator can calculate 2 independent functions at the same time. So we are just using one. So just press enter. Just press equal sign. Start. That's good. And that's good. Let's do it 20. Let's put 20 here. Okay, 20. Then press enter. And we will have insufficient memory. Our calculator cannot do it because of insufficiency of memory. And therefore, let us, because we already know the value for 340 and negative 340 and negative 300, let's start with negative 220. Okay, let's start with that. Okay, so let's go back. Let's start with, instead of 340, let us start with negative 220. Negative 220, because we already know the answer for negative 340 and negative 300. So let's start this. Press enter. And 80 step. We can use the step 40. We can use the step 40 here. Okay, and then we have the table. Okay, for negative 220 degree Fahrenheit, what is the value of our prediction? Okay, 4.0454. The prediction on the textbook is 4.05. Oh, so we are equal, no? We have an equal. We already have this answer, no? Before. We already have this answer before. So let us do the step 20. Let us do the step 20 here. Okay, step 20. Okay. So let us go to the negative 160. Okay, negative 160. This one. What is the estimated value? 4.7035. The same answer with the textbook. 4.7. Okay, same answer. Next is negative 80 degrees. Our answer is 5.44. Textbook answer 5.44 equal. Okay. Next, 0 degree Fahrenheit. Let's go to 0 degree. Our answer is 6.02. Textbook answer 6.02. Okay. So meaning to say, this is a numerical application. This calculator. No? So let us go to 40, positive 40 degree Fahrenheit. Our answer is 6.25. Textbook answer 6.25. And lastly, let's go to 80 degree Fahrenheit. The answer is 6.45. Textbook answer 6.45. The same. Right? So we got all the correct answers. Okay. I hope you are able to follow using your calculator. If your calculator is the same, good for you. If your calculator is not the same with this model and this brand, you have to do it on your own. You have to discover it yourself. Okay. Do you know that I enrolled in a review center just to learn how to use calculator? Okay. I took the board exam for 5 different licenses. Okay. I took the board exam for 5 different licenses, but I only took a review for 1 of those. Okay. I did not review on the other 4. I only review for civil engineering. Why? Because I don't know how to use calculator. After I learned how to use calculator, I did not enroll in the review center anymore. I self-studied. and took the other 4 board exam, I passed all the 5 board exam. Okay? Within 1 year. Actually, within 10 months. I passed all the 5 board exam within 10 months. Okay? I only review once for civil engineering because I do not know how to use calculator. And that's why I would like you to give importance to this use of calculator because I am giving this to you freely. I am not asking for any monetary consideration. I paid 15,000 to the review center just to learn how to use calculator. Okay? And I am giving this to you freely. Okay? So that's why I would like you to do it at the same time while I am doing it. Okay? Don't just listen to me. Do it. No? Use your calculator and practice it. Okay? Okay? So let's go on to the next problem. And because we have a tabulated result, we can graph those tabulated results. And because we have the correct or similar answer to the textbook, so we can have what? We can produce the same graph like this. We have the same graph. Okay? So that is the same thing. If you don't have calculator right now, use your Excel. You can do it in your Excel. The same thing. The same input function. Okay? The same input function. So, okay, example of truncation error. This is just an explanation. There is no problem solving here. Truncation error meaning if we are only using what? Four terms. 1, 2, 3, 4. Therefore, the rest of the terms will become error. Okay, will become an error using Maclaurin series. So, therefore, we already have an idea that calculators and Excel are using what? Maclaurin series and Taylor series. Okay, Taylor series. Okay, they are using Taylor series. They are using Maclaurin series for most of the estimation requirements. Okay, so they are using those things. How they compute? How our calculator compute? How Excel compute? They are using Taylor series in order to estimate. Okay, so next okay, this is again just an explanation. Explanation.
Get out. Are you bringing the phone?
Okay. I think this is the next problem. This is the next problem. Oh, example. Okay, we have an example here. Calculate the value of E. Okay.